Hello everyone, today we are discussing one example on slope deflection equation. So for example 1, let us determine directions and draw the shear and bending moment diagrams for the beam. Okay, so let us write down the equation for MAB using the slope deflection equation. 2EI over L, 2 theta A plus theta B minus 3 delta over L plus FEMAB. If it is AB, so your FAM will be AB. Okay, so that's very simple. If it is MVA, so the same. 2EI over L, 2 theta B plus theta A minus 3 theta over L plus FEM BA. Okay, so just remember, if you have BA, you will have FEM BA. Okay, so next, so with and to put in all the values, L is the length of the spanner, not 2 and not 3, it is 5. For theta A, it is 0 because it is a fixed end moment. There's no settlement, so just write it as 0. Okay, the same goes to MBA, it is 5. 2 theta B is 0, and 0 plus FEM BA. Okay, let us look on FEM for AB and BA. So we look into span AB first. Okay, for span AB, you have point A and B, length 2 meter, 3 meter here. This is 90 kilonewton. Okay, so for FEMAB, what is the fixed end moment? So we have to refer to the reference book. Okay, to refer to the table at the last page at the cover of the reference book. Okay, so for the first one, we will be using this. You'll be using this formula. Okay, PB square over A. Another one on the right hand side, we're using PA square B. Okay, so you have to differentiate. Okay, for the left side, you use PB square A. For the right side, you use PA square B. Okay, so for the left side, we'll use PB square A. For the right side, we'll use PA square B. Okay, so you have to remember, okay, in fixed end moment, okay, the left one is always the anti-clockwise, and the right hand side is always clockwise. Okay, so for anti-clockwise is negative, and for clockwise is positive. So remember to put the sign. Okay, so the first one is negative 90, B is 3, so this is A, this is B. Okay, so B square, A is 2 divided by the total length, 5 square. Another one, A is 2 times 3 divided by 5 square. So you will get the answer by pressing a calculator. So you will get, the first one is negative 64.8. And then the other one, you get 43.2. Yeah, it is a positive. Okay, so we can just put in the value here, FEMAB. So it is negative 64.8, and for this, it is 43.2. Okay, so let us simplify this. So you get 205 EI theta B minus 64.8. This one is 405 EI theta B plus 43.2. So this is our first equation. This is our second equation. Okay, let us move on to find MVC and MCB. So 2EI over L, L is 6, multiplied by 2 theta B. For theta C is also 0 because it is a fixed end moment. There's no settlement, so minus 0 plus FEM BC. Okay, same goes to this one, 2 multiplies 0 because theta C is 0 plus theta B minus 0 and plus FEM CB. Okay, so let us draw out for fixed end moment to determine fixed end moment. The length is 6 meter, and we have the distributed load uniform UDL of 50 kilonewton per meter. This is the side B and this side C. Just remember, for the left hand side is always negative, right hand side is always positive. Okay, so for FEMBC and FEMCB, you will get, what is the formula? This formula you have to remember. it is WL square over 12. Okay, WL square over 12 for uniformly distributed load along the full span. Okay, so let us see here WL square over 12, square of 12. So you will get, what is W? W is 50, the length is 6. Okay, this one is also the same. So you might get 150. This one is a positive. So just replace it here. Okay, so multiply it. 4 over 6, you get 2 over 3. EI theta B minus 150. 1 over 3 EI theta B plus 150. So this is equation 3. This is equation 4. Okay, so we have to recall one important thing, which is the joint equilibrium equation. Okay, joint equilibrium equation, we have to see this is a roller at here. Point B is a roller. Okay, at joint equilibrium at joint B. Okay, so the direction, okay, the direction produced by the roller support is always a vertical, okay, vertical direction. So the moment at point B is 0. Okay, the moment at point B is 0. Okay, so at point B, let us see here. Okay, what is actually MAB, MBA, MBC, and MCB? So we have to remember, okay, when we start a question, we always assume that the moment is at the positive side. Okay, what is a positive side means? It is always clockwise. Okay, so let us draw clockwise, always something like this. Okay, always assume it is positive. So this is MAB, this is MBA, this is MBC, this is MCB. Always assume, okay, the moment is clockwise. Okay, so let us look at here at this point, at joint number B. So what are the equations that you can get? MBA plus MBC is equals to 0. Okay, because they will counteract each other. Okay, so we can write MBA plus MBC equals to 0. So we just substitute equation 2 and 3. EI theta B plus 43.2 plus 2 over 3 EI theta B minus 150 equals to 0. So let us calculate using calculator. 50 minus 43.2, you'll get a 106.8. So theta B, EI, move over the right side to become a denominator. 168 divided by 22 over 15, you'll get this one. Let us write in fraction, it will be more accurate. Okay, so we get theta B. So after you get theta B, actually when you substitute into all the moments, you'll get the answer. Okay, so when we substitute inside, what is MAB? Here we can get the values. Okay, these are the values that we obtain. Okay, look back to the figure of the beam. Okay, what does it mean? Negative 35.67. Negative means the opposite direction. Okay, it is the opposite direction of the direction that when we assume previously. Okay, so negative is actually the opposite direction, so we can write it like this. Correct or not? Okay, it is logic. Okay, how about MBA? MBA is still the same because it is a positive. Okay, how about MBC? It's negative. That means it is a different opposite direction. Okay, how for MBC? For MCB, it is the same because it is a positive answer. Okay, okay, so let us move this down and we can start drawing the diagram, the moment diagram. Okay, the moment diagram. Okay, so here I'll just delete it, remove it first. Okay, So first one we'll get 35.67. Another one 101.45. Last one 174.27. Okay, after we get a moment, we need to find the shear. How to find the shear? So we separate them into their own spans. Okay, span AB. Okay, 35.67, 101.45. Here is a 90 kilonewton. For next span is span B to C, 101.45, 174.27. Okay, so what is the next step we need to find? We find the shear force. Okay, so I will write this down. So here will be 50 kilonewton per meter. Okay, so this is very simple. So use the equation of equilibrium to find the separate span, the individual span. So for here, you can get VB is a positive, okay, at point A. So VB multiply the distance is 5, okay, because this is 2 meter, here's 3 meter, okay. So minus a 90 multiplies the distance from A, okay, so positive plus 35.67 and minus 101.45. So VB you will get, let us put in the calculator and calculate it. So I can get 49.156 kilonewton. Is it okay? You guys can check whether the answer is the same as yours. Okay, so for VA, okay, to find VA, we use the equilibrium of force in the y direction, assuming this is going upwards. So VA plus VB minus 90 equals to 0. So VB will be 90 minus 49.156. So you will get 40.844 kilonewtons. Okay, so let us calculate for span BC. Okay, the same goes to point B. Yeah? The total moment at point B is equals to 0. Okay, so for VC, multiplying the distance is 6 meter. Okay, minus 50 times 6 over 2. Okay, it is negative because the moment, okay, is going in clockwise direction. Okay, so for 101.45 it is a negative, and 174 is also negative. Okay, so it equals to 0. So can we find VC? Okay, I think I made a mistake here. The negative 101.45 at MBC should be a negative, so it should be this direction. Okay, sorry, I've made a mistake. Okay, so it should be this direction. Okay, so from here we can get a positive on that. That will be correct. So yeah, the answer is correct. 1137. Okay, usually I write in 3 decimal places. Okay, so for finding VB, the same, plus VC minus 50 times 6 equals to 0. So VB is 50 times 6 minus 162.137. So you get 137.863 kilonewton. Okay, so after we obtain these values, can we draw the shear force and bending moment diagram? Yes, of course. So let us draw it. So this is A, B, C, put it longer. Yeah, C. Okay. So the first one is shear force diagram. Another one here is bending moment diagram. Okay. So for A, let us start. 40.844. Okay, so somewhere here, 40.8. All right. So is there any force? No. So it remains a horizontal line. Okay. Okay. 40.844. So we move down 90. So minus 90. You go to negative 49. Somewhere here, negative 49.156. So still remains constant until B. So B for the first part is 49.156 going upwards, so plus 49.156. Okay, you will go up to here, and then we will move up until 137 point. I move down a bit. Okay, so here you'll get 137.863. Okay, okay. So now we are at point B. Okay, starting from point B, we have a UDL. So UDL means you have a linear line. Okay, linear line. So move until 50. Okay, minus of 600, minus 600. So you're minus, minus 300. Okay, minus 300. Okay, so you'll go on to 162. 1, 2, 3, 4, 5, 162. Oh, somewhere here. Negative 162.137. And lastly, point C is going upwards, 162.137. So get back to 0. Okay, so is it very easy? Yeah, it's very easy. So how to find the distance here? Okay, by using the triangle method. Okay, so this is our x value. So x over 137.863 will be equals to this will be 6 minus x. 6 minus x over 162.137. So let us obtain our x value. So x is 2.757 meter. Okay, so I'll write it 2757. So 6 minus 2.757. So you can get 3.262 to 3.243 meter. Okay, so can we draw the BMD, bending moment diagram? Yes, of course. So move here. Okay, make sure you can draw a line here. Okay, this is the center. Okay, this is the point we calculated from the shear force diagram. Okay, so for the first part, you have 2 meter here, 3 meter. Okay, at point A, okay, what is the moment? 35.67. Okay, so 35.67 is a going to the, this is negative, upwards is negative, downwards is positive. Okay, so for the first one, is a positive or negative? A negative. Okay, 35.67. So go up 35.67 somewhere here. Okay. Okay. So and then what should we do? Get the area from the bending, from the shear force diagram. So plus, this is positive, negative, positive, and negative. Okay. So plus 41.844 multiplies by 2. So you get 46.018. Okay, you will get somewhere here 46.018. Okay, okay, and then minus what? Minus the part, this part, minus this part. So you get 101.45. So go up again, 141, maybe somewhere here. It is a negative. Okay. Okay, after that, remember at point B, the moment is 0, so actually we don't need to find the moment. Okay, it remains at negative 101.45. Okay. So next, let us continue to find the answer. So minus 101.45, you might get, you add the area of this triangle. So add 102, 137.863 times 2.757. You will get 88 something. So it is a curve. So somewhere here, maybe here. So it is a curve 88.594. Okay, and then lastly, the last triangle, so minus what? Minus the area of the triangle because it is a negative. Okay, negative 174. Negative means upwards here, maybe here. 174.311 minus. So going up. Okay, so I will draw it back. Drawing seems a little bit ugly. So here, okay. Okay, now we have negative 174.311, negative. And lastly, what is the value here? The last moment, 174.27. So it is a positive or negative moment. So look at the direction. Okay. Okay, we can see it is a clockwise direction. So when we draw, a clockwise direction should be a positive moment. Okay. If it is clockwise, it is a positive moment. Okay. Positive means going up, downwards, positive. Sorry. Okay. So minus 174.311. Okay. You add 174.27. Okay, it's actually negative 0.041. Okay, it is considered as 0. Okay, if you take a small, if you take less decimal places. Okay, so I think this is the final answer for this question. Okay, the left hand side is the shear force diagram, and the right side is the bending moment diagram.